Hi, and welcome to Lab 5. This lab is about some of the most common things that you need to be able to do in order to complete a GIS analysis on your own. And that is finding data and pre-processing that data so that it's suitable for use in your analysis, and then building a GIS database, which really just means creating a file structure so that your data stays organized. Often when you're doing an analysis, you're going to download a bunch of different data sets, and then you're going to do things to those data sets that create both intermediate and then final data sets. And if you don't keep track of them, it can really become a mess, and it can become a mess very quickly. And so I don't want you to have to go through that, because sometimes it becomes such a mess that you have to just scrap it and start over, especially if you have to leave your project for a while and then come back to it a couple weeks later. You may have no idea what you're doing. So this is going to guide you through some of those basic processes. So as always, the lab is on Blackboard. You're going to start out finding some data. So I guide you through it a little bit, but I'm going to leave it up to you guys to actually find the data sets that you need. I have structured this lab. We're kind of pretending that we're a GIS analyst for Chase County, Kansas, which is where the Tallgrass Prairie National Preserve is. If you've never been there, it's lovely and you should go. It's not too far of a drive from Lawrence. But say you work for the county and a company wants to do some construction in the area, but everybody wants to make sure that that's not going to negatively impact the ecosystem of the Tallgrass Prairie Preserve. So to begin that analysis, you have to get some data, right? And you have to think about the problem and what data you might need to do this analysis, right? And there's a lot of data sets that you could try and find, but I was thinking that the basics, first you need a shapefile of the county, Chase County, Kansas, because that's going to be your study area. All of the analysis that you're going to do is going to be in that single county, so we need a shapefile of that. We also want information about the current land cover of the area, whether it's prairie, whether it's water, whether it's cropland, things like that, because you know, those types of areas would be impacted differently by construction, right? Water bodies also, like I said, because we also want to make sure that the construction isn't going to negatively impact the watershed. You know, there are erosion concerns, pollution concerns. And then also we want to know about the road system, because roads are already impacted areas. So if the new construction was maybe alongside of a highway, it wouldn't do as much damage as it would if it was in the middle of a prairie, right? And also, they're going to need construction teams are going to need to get to this site where they want to build. So if there are existing roads, that would be helpful as well. So I do guide you to where you can download the data. So it is the Data Access and Support Center for the state of Kansas, which is known as DASC. You ever hear people talking about DASC? This is what they're talking about. And it's a geospatial portal, just like the one that we used in the lab where we downloaded data for Philadelphia, except this is the state of Kansas. And so you do need to register an account before you can download any data, before you can even really see the full extent of what's available. So I do need you to sign up. It's free. They're not going to contact you about anything. They do ask for an address and a telephone number. And if you like, feel free to use the address and the telephone number for the geography department. I've included those here for you. Definitely use your KU email. Again, they're not going to sell your information or anything like that. I don't think I've ever gotten an email from them. So there are 6 data sets that I'm going to have you download. I don't tell you how to find them. I don't tell you exactly what they're called. I just tell you what they are, and I want you to be able to find them. Because if you had decided, if you were doing this on your own, you decide that maybe DASC is a good place to look because you did a Google search for Kansas GIS data, and that's what came up. This is how you would need to navigate that site, right? You need to click around, you need to see what's available, and then find the data that you need. And there are multiple ways to do that. There's a file structure that you can just browse. You can also search by terms, but I think it should be pretty easy for you to find these data sets there. I definitely have specified the years and kind of the data source for them. It is important. All of these data sets can be downloaded as either an Esri shapefile or a file geodatabase. And you'll see that when you find a data set and you click on the download tab, those will both be listed. You need to download the Esri shapefiles and not the file geodatabases. File geodatabases are just a different way to structure the data. You can use them in ArcMap. Some people prefer to use those instead of shapefiles. They both have pros and cons, but it's a different structure than what we've used before, and I don't want to introduce this into this lab. So download the shapefiles and not the geodatabases, otherwise you're going to have problems. And so all 6 of those data sets are listed here. So you're going to need the counties, land cover, water bodies, flow lines, which are streams, state highways, and non-state roads. And so I expect you to be able to find those on your own. Also, for those of you who are using a virtual desktop through the virtual lab, I definitely recommend logging on to the virtual lab, using a browser on that virtual desktop, downloading the data to your OneDrive on the virtual desktop and using it that way, versus finding the data and downloading it on your own computer and then trying to access your data through the virtual desktop. These are kind of large data sets, and when I did that, I had issues. So again, download it on the virtual desktop. Log in before you do anything, and then download the data there. All right, so I am already logged on. There we go, to the virtual desktop. So again, what I'm talking about for those of you on the virtual lab, you know, use a browser here. I always use Chrome, whatever you like. But open that browser here, navigate to the site here, and then when you download it to your OneDrive here, okay? And you know, it's good if you have a Geography 358 folder here. It's best for you to do your work there, save it there, export your PDFs there. You'll be able to access that data from your Mac or your home computer, the PDFs or PNGs when you need to turn those in. But this way, all of the geospatial data is being handled on this virtual lab machine. It's just much faster that way. All right, so you have your lab or your map document. Let me do this. All right, and so I also instruct you to, I've already done all of this, but so you're going to want to create a Lab 5 folder, and in that folder, and it may be easiest to do it here, so create a Lab 5 folder. In that folder, create 3 folders, and so you can do that with just a right click, new, and then folder. One is called Data Raw, and that's where you're going to download your data to. One is called Data Project or Data Proj, which, you know, just a nice abbreviation. We're going to project our data, so that's all in the same coordinate system. And then you want a folder called Data Clip, because then we're going to clip all of our data to just the county. So clipping is a very common geospatial process. Clipping essentially is like a cookie cutter. You have some feature, a shapefile. So in this case, it will be our county, and you use it to cookie cut out all of your other layers. So then everything is just reduced to the size of your county. Because otherwise, if you wanted to do some kind of analysis, all of these data sets that we're downloading are the size of the state of Kansas. They're for the entire state. So doing some analysis on all of that data is unnecessary because we only want it for the county. So it's going to save you time, it takes up less space, and it's going to be more accurate, easier for you to keep track of because it's specific to your project. All right, so create those folders. This is where you want to download your data. And then they're going to come to you as zips. You need to make sure and unzip them. So again, that's the extract files. Okay, let's come back in here. In that, so it stays there. All right, and so the first thing you're going to do is project the data. Usually when you work for an agency like our pretend Chase County GIS agency, they like to use one projection for all of their files, because that way there are never any issues with interactions, inaccuracies because of different projections. Everything is just organized from the very beginning. So it's a common first step. When you download data, you want it all in the same projection. And so what we're saying is that this agency that we're working for, the data projection that they use is state plane, which we have used before. So Lawrence is the Kansas North state plane zone. Chase County is in the Kansas South zone, all right? So I'm going to show you a different way, and this is detailed in the lab manual, a slightly different way to do this, because we have 5 shape files, and we want to do the same thing to each of them. So instead of opening the tool, running the tool, letting it finish, opening the tool, running the tool, letting it finish, we can do something that's called batch running the tool. So we can say, I want you to do this to all 5 of these files, and then you just let it go. And it does that to all 5 of those files. So, oops. I'm going to have you come to this search bar. If you don't see it here, you can just click on it here. It's this icon that's like a window with a little globe on it. I like to keep mine pinned to the side over here because I find that I use it frequently. All right, so come in here and then search for project. And so this is the same tool that we've used before. It's this project data management tool right here. So instead of clicking on it, you're going to right click and then select batch. And so it opens this menu here. So we're still in the project tool, but here we can add multiple input data sets. So the first thing that you need to do is double click here. Oh, and actually, sorry, first I have you go back. Add in all of your data. Add in all of your data so that you can kind of explore it a bit. That's definitely a good first step in any analysis. Actually look at your data, make sure it is what you think it is, because sometimes it's not. And you get a sense of how it all fits together. So like I said, these are kind of large data sets, so sometimes it takes a little bit of time to come through on the OneDrive. All right, so I'm just gonna load in 2. Because I've already worked through all of this. And so you're gonna get errors like this or warnings that these are not in the same coordinate system. That's fine, because that's exactly what we're gonna take care of. All right, so back to search here. Right click and batch. All right, so the first thing you want to do is change your environment. This workspace is just saying, when I run this tool, I want everything it does to be in this one folder. So if we change this, the default will be to save it to exactly where we want it to save. So you need to change this to your Lab 5 folder, and then this, data project, because that's where we want to save these files. So then highlight this and just click add. And then you want to do the same thing here for your Scratch workplace. You can also just copy and paste that here, or you can navigate to it here. It doesn't matter. But so change both of these workspace settings and then say OK. And so now we can add our first input data set. So double click here. And if you've added all of your data sets, your raw data sets into the map, you would see those here in a drop down. So you can select them that way. I have not, but you can find them here. So find them, say add, OK. And so you can see it has input that here. And then if you hover your mouse over this, the output data set, you can see that it is automatically being saved in our Lab 5 Data Project folder, and that ArcMap has appended the word project onto the end of the file so that you know what the original shapefile was and what's been done to it. And so we can just accept that. You could also change it if you wanted. So right click here and then say open. And then you could change the name if you wanted. Mine has a 1 here because I've already done this. So I already have a file called this project. But so then you need to set the output coordinate system. So again, double click here. And so you are going to navigate. Let's see. All right, so projected coordinate systems, state plane, NAD 83 meters, right here. And then you want Kansas, south. And so highlight it and then click this star and it will add it to your favorites so you don't have to go through that navigation again. And then click OK. That's that here, OK. And so that's all the information we need there. We've got the output coordinate system, what we want the output data set to be named and where it should be saved, and then our input data. And so then you just click this add and you do it again. Go here, or if you have the drop down. And so you want to add all of these vector files. And so again, you can see that it's being saved where we want it to be saved and named something that makes sense. And now you can see this is the coordinate system that we want, and it's just right there in our favorites. All right, say OK, OK. And so you're going to do that to all 5 of the vector files that you've downloaded, because you're downloading 5 vector files, which remember are points, lines, or polygons. And then one of the files, the land cover data, is a raster. So you are going to add all of those vector files. So it's 5 files. And then once you're done, you hit OK. I'm going to hit cancel because I've already done it. And then your tool is going to run. And then you will be able to see that all of your data, when it's finished, has been added in here. So we have all of these with this project on the ends. If you want to check the status of that tool as it's running, you can always come up here to geoprocessing and then results. And then this will have a plus next to it and you can expand it. You'll see the tool that's running, which will be the project tool. If it still has a little hourglass next to it, that means it's still running. When it's done, you should see all of those files here in Data Project. So then you need to project the raster file, which is similar, but just a slightly different projection tool. So search here for project raster. You want this tool here. You don't need to batch it because we're only projecting one raster. So open this tool. And then your input raster. is going to be your land cover raster, this image file here. And then you need to specify where you want that saved and what you want it to be called. We didn't set the environment, the workspace in this tool. We're just going to change it here. And of course you could have, but you know, we're just doing this one. So you want to highlight this data project, and then you want to name your output raster. Now for some reason, rasters with only one band, which is what we have, can only have 13 characters in their name. So you want something short and informative. So I'm gonna call mine LC project for land cover project, right? So we're gonna save it here, we're gonna call it that. You can see that here, oops. There we go, I guess you need to do it like that. So land cover project or land cover proj, and then set the output coordinate system. Again, we've already added it to our favorites, so you can just say okay. It automatically adds a geographic transformation, and then you just hit okay, and it's going to project your raster for you. And so some of those may be added to your map document, some may not. I'm never quite sure why it adds some and why it doesn't add others, but that's okay. So the next step in processing that raster is we want to transform it to a vector. So vectors and rasters are very different. ArcMap handles them very differently. You'll recall that a raster is just a grid of pixels. Each pixel has only one value because we only have one band. And so ours is a land cover data set. So each one of those pixels, which are 30 meters by 30 meters, is gonna have one land cover value. So something like prairie or forests. I think there are like 17 classifications. And so we want to change that into a raster. And so there's a very handy tool that does that for you. So we want this raster to polygon tool because you know, some of the analysis that we want to do may be a lot easier if we have this as a vector file. Just depends on what we're doing, but a lot of times calculating areas within other areas, looking at intersections and unions, things like that, buffer distances is much easier if you have a vector file instead of a raster file. So search for raster to polygon. And it's this tool here, this conversion tool. So you want your input raster, which is going to be in your projected data. LC projects, yep. And then you need to specify this field value. So the field that we are interested in is the land cover. So change that here. And then you need to specify where you want that saved. So you still want that in this data project because it hasn't been clipped yet. So I named mine LC Poly Proj. Name it whatever you want, but something so that in 2 weeks, when you've decided, you know, you've forgotten about this lab and then you're like, oh man, I really need to finish it. You can come in here and know exactly what these files were because you've given them informative names. So this is land cover, it's the polygon, and it's projected, right? That's it. Just keep this checked right there and then say, okay. This is giving me an error because I already have that file and it doesn't want to overwrite it, but you shouldn't have that problem. So run that tool. That one can take a while because it's a pretty big data set. But again, you can use this geoprocessing results to see if the tool is still running. All right. So once you have everything projected, we need to clip it to our study area. So the first thing that we need to do is create our study area because what we have for the counties is all of the counties in the state of Kansas, and we are only interested in Chase County, right? So we have done this before. You need to just select Chase County. So you want a select by attribute query, which means you want to open the attribute table. So you can just right click and then open attribute table. It's always a good idea to look at these fields so you can figure out which one has the information that you need. So for us, we're interested in the name, right? So we want to look at this name. So you're going to come up here to select by attributes, and then you need to create an attribute query. Now I don't want to show you how to do this because you should know at this point. We've gone over it. If you need to, you can go back to previous labs. I have put a hint, probably pretty obvious hint in the lab document to help you do that, but you should be able to figure it out, especially with this hint, and if you need to, going back to previous labs. But so once you have that, I'm just going to pretend this is it. One row, the Chase County row in this attribute table is going to be highlighted. You can just close, and remember this, I'm just pretending because I don't want to show you how to do this. We're pretending that this is the county we're interested in. And then you're going to right click here, come down to data, export data. This should automatically say selected features. It can also be all of the features in the layer, all the features just in your view extent if you were zoomed in, but this is what we want, selected features, because we are exporting just the one county as its own data file. This is correct. We want the layer's source data, which means that it's going to have the same projection as this county layer that we're exporting it from, which is correct because we just projected everything. And now you need to specify your output feature class. So this one will go in your data clip because although we're not running the clip tool, we're essentially doing the same thing because we're getting rid of the excess data. We're going down just to the one county. And then you need to make sure and change this here because again, we're not dealing with a geodatabase, we're dealing with shapefiles. So call it something like Chase County, right? And then all you have to do is hit save. And it is going to export that as a single feature in a shape class. So it should look like this. So this is your Chase County. And you can zoom out and see that's the only one, right? Zoom back. So now we have our Chase County. We can use that feature to clip all of the other features. All right, so we're gonna do the same thing as we did with the project. We're gonna batch that tool. All right, so again, come to search, look for clip. And you want this clip analysis. So this is in the analysis toolbox, not this that's in the coverage toolbox. You're almost always going to use this one. I don't think I've ever used this coverage tool. So again, you right click and you batch. And then, so this is just the same thing. You're going to input your features. If you have them in the map, you can access them here. You can double click. All right, first, you want to change your environment again, but this time to the clip, because that's where you're going to be saving this. So change that there, change it here, okay. Now we can add our input features. So these are going to be all of the data sets that have been projected. We no longer want the raw data, we're working with the projected data. So just as an example, you're going to add all of these data sets because now they're all polygons or, they're all raster files, so they're all going to work with the same tool. You add one, okay. Your clip features are your county. So for me right now, I already have it in my map, so I can just access it here. If you didn't, it would just be the same thing. You find it here in your clip. Either way, it's going to be the same thing. And then your output file should already be set because you've changed your environment. So you can see it's saved in the Lab 5 clip folder. It's called State System Project Clip, or most of the word clip. And say, okay. Oh, no, sorry. That is all that you need to specify for that. So then again, you just click add, come in, and you want all of the data in your clip folder, except you don't need to do this to Chase County because remember, it's already been subset down to exactly what we need. And so you're going to do that to all these files, and then once they're all here, so it's going to be 5 again, you hit OK, and it's going to run that tool, the clip tool, for each one of those files. And so that's it. I know it's not a very glamorous lab, but when you're done, you are well on your way. You have a very organized data structure to do an analysis. And you can see exactly what you've done, how you went from here to here to here. This is the data that we're going to use. If we do anything that messes it up, we still have the other stages of the data. We decide that we want the neighboring county as well. We have it. We can go through these steps again. And so after you have done all that, I want you to make a map. So you guys should kind of know the drill on this one. You're going to want to make sure and put these in an order here that makes sense. Remember that whatever is listed on the top in your layers here, when you have this selected list by drawing order, is going to be on top. So like your land cover, you can't see it right now because it's under this Chase County. So I would recommend making this hollow. Maybe you want to make the border big and bold, which really you don't need because everything is clipped to this, but I want you to have all of these layers in your map. So now you can see all of these polygons. Remember that if you want to show each unique value, which you should in this map, you can come here, double click on your layer, come to symbology. Also, you can change the layer name here, just like you can do it in the table of contents, which remember you want to do because if you change the name here, it's going to look nice in your legend. Don't change it, it's gonna look like crud in your legends. And nobody except for you is gonna know what LC underscore poly underscore proj underscore clip means, right? Especially if you're presenting that to a board of trustees or something, that just looks sloppy, it's not professional. So we can say something like land cover types. And then under symbology, come to categories, unique values. Make sure and change this value field to land cover, and then you can add all values. And so there it has all of your different values. You can change the colors here. I like to use something that, I don't know, is a bit bolder, has a bit more contrast between the different types. You could also change these manually if you want. You can just double click on them. If you wanted to say make all the forests different shades of green, and then cropland shades of brown, water blue, that would be really nice. But so you can change that there or one by one. If you want to change the label, you can do that here under this label. You can just double click there to change it. But these are pretty good names. And then just say okay. And now they're all listed here. Oh, and one more thing that I like to do there is unclick this all other values so that it doesn't show up in our table of contents. And you can also delete this again so it doesn't show up. So now when you add your table of contents, your legends, sorry, you'll have all of your layers here, symbolized in a way that makes sense. I hate legends that are titled legends. I think it's dumb. I think it looks sloppy. We know what it is. You can also change the background here. So often I'll give my legend a white background. So I'm gonna zoom in so you can see this. So because it has that white, it can kind of overlay something. Of course, you do not want to overlay this because, this is the point of your map, right? But I would remember that these tools here, ones with the page on the back, are just working with this map document. So if you zoom in, it's just zooming in on the document. You can go to the full extent here. If you want to zoom in on the map, you have to use this one. And so you can also, with this select tool, move things off to the side so that you can work with everything else. But make sure that when you're ready to export your map, everything has to be on this page. Otherwise, it's not going to export as part of your image file. I like to make this outline the size of the whole page. So you can right-click, distribute, and then fit to margins. And it will do that for you. And then zoom in on your map. Usually you want it as large as possible on your page. So then we could move it up so that we have some room. Another thing that you can do, and this is maybe a bit advanced, but double clicks here. Let's see, how do you do it? Oh, you can create columns. Okay. Oh. Where did that not work? Let's see. Oh. You need to highlight which one you want here. So this is the really long one, right? There's only one Chase County. That doesn't matter. And make some columns here. And so now it's given you this nice horizontal legend, which fits a lot better on the page, right? So make sure that you also add in your north arrow and your scale bar. It's very important to give this an informative title. So at the very least, it should be something like land cover types in Chase County, Kansas. You could even add in something, prepared to do analysis for possible construction or something like that. That might not be necessary, but you need to say that this is Chase County, Kansas, and that this is a map of the land cover types. And then of course you'll also have your highways, your roads, your water bodies, your streams in there as well. All right, let me know if you have questions, and good luck, have fun.